Time to do some science experiments. Get that light just a little better there. Welcome, everybody. Welcome, everybody. Let's do some science experiments. Well, I don't know what we're doing tonight. We're doing a bunch of different stuff tonight. We got some dry ice for later. I got some color separation experiments ready. And, of course, we have our acid-base reactions as well. Let's get this flask over here filled with some deionized water. There we go. Pop it in there. Yeah, these are very different sized flasks. The one on the right is about I'm going to say about a liter. And the one on the left is about 4 liters. How you doing, Giga Bean? Good to see you. We got a bunch of different experiments tonight. At least 3, I'm thinking. All right. Let's add some universal indicator to this flask over here on the right. Universal indicator is also known as rainbow indicator. Changes color depending upon pH, which is how acidic or basic something is. I think I want to slow the speed down just a bit. All right, let's add the universal indicator. And we see a yellow color develop. It's green at first. You can see the universal indicator that I'm adding is green. And then when it goes into the purified water, it shows a yellow color, which indicates slightly acidic. That is correct. That purified, it's not completely pure, but water that's mostly pure is going to be slightly acidic. And the slight acidity of purified water comes from carbon dioxide in the atmosphere. So if any carbon dioxide dissolves into water, which happens if there's any air around the water, the carbon dioxide is going to get into the water. It's going to make it slightly acidic. So here's the different pH values and the different colors that you'll see. Here, let's get this light on so you can see it a little better. So this flask over here on the... I got to plug her in. I got to plug this thing in. Where is it? Get this thing out. So this is out. And we got to get this one in. Sorry about that. I want you to see the different colors that this indicator can display at different pH values. Here we go. That's a little better. So you can see here, this flask on the left, the larger flask, is like pH 3, which is quite acidic. This flask over here on the right is just slightly acidic, pH 6. So I'm going to start adding, let's try adding a drop of sodium hydroxide base over here on the right. See a nice blue color develop in. Oh man, that went from pH 6 to pH, I don't know, 10 pretty quickly. Oh, I don't know if I'm actually synthesizing anything or not. Don't get to do too much acid-base chemistry, but got to make up for some sodium phosphate buffer. Nice, Dunkel. Nice. Let's add some base to this flask over here on the left. There we go. What do y'all think of the get-up I got tonight, huh? What do you think? We're doing some chemistry experiments, baby. Come on now. Except I'm not Breaking Bad. I'm making good. All right, let's get back to the chemistry here. There we go. Thank there, Andres. Appreciate that. How you doing, Adiant? Thanks there, Noah. Y'all let me know what you think about the cosplay here tonight. Let's add a little bit more base over here on this side. We'll flip it around, let you see that every once in a while. Yeah, if we get bored. Add a little bit of acid over here. Same acid that's in your stomach. I'm adding hydrochloric acid over here on the right. Oh, look at that. Beautiful color developing over there. I got to get this down just a bit so we can see more of the colors that are on the larger flask. This is Breaking Bad if Skylar didn't exist. Oh, Lucas. Lucas. Here we go. Let's add some more base over here on the left. That's a really big flask over there on the left. Let me get that light off too. I don't like that circle light. It's taken away from the colors. I think I can get this off too. There we go, baby. Come on now. Look at all those beautiful colors. Beautiful. Let's get some base over here on the right going on. Nice stuff. Nice stuff. I don't know if you can see me in the dark, huh? Maybe that looks a little better, huh? In the dark. Back to the experiments. You guys don't want to see me. You want to see the chemistry. So, Owen, what we are doing here is in each of these flasks, I have some universal indicator. Universal indicator is also known as rainbow indicator. That's because it displays the colors of the rainbow depending upon pH, which is how acidic or basic something is. So if I look over here on this flask, it's red. That tells me it's pH 3, which is quite acidic. The lower you go on the acidity scale, the pH scale, the more acidic the solution is. Over here on the right, that's almost green. I mean, there's a bunch of different colors in there, which means there's a bunch of different pH values, but it's mostly green. And that green tells me that the flask over here on the left is neutral. Watch what happens, though, when I start adding base to both of these. Here we go. Let's add a little bit of base. A little bit of base over here on the left. And what you see in the basic solutions, the colors are going to be more blue or violet than green. And in the acidic solutions, the colors will be like yellow, orange, and red. All right, we got rid of Big Boy. That didn't take long. Oh, yeah, I don't mess around with that kind of crap. So you want to take your racist bullshit elsewhere. I don't know if YouTube allows you to swear, but for crying out loud, people, it's 2023. What's going on, Preppy? What's going on? Check out the outfit I got on tonight, huh? What do you think? We're doing some chemistry experiments, so I thought I might go ahead and dress the part. Hope you all like it. I even grew this for you. I don't know if you noticed that. 2023. Oh, I just said it's 2023. Thanks there, Owen. It's 2025. Guys, keep me straight. I appreciate it. Oh, man. And we got another one that we're getting rid of. There we go. What's going on, Dark? Great to see you. Great to see you. We're doing some chemistry experiments. I got some pretty cool stuff ready for you tonight. We're going to do some cool chemistry experiments. I don't have any nitric acid, Darky. However, it's just a little stir bar. So there's just a little magnetic stir bar down here that's on a magnetic stir plate. You know, the video I put out last weekend, you want to see it there, Chad? Chad wants to see the Heisenberg, huh? What's going on, folks? Okay, so I totally forgot. Oh, yeah, the nitric acid. So the video I put out last Saturday, the short video I put out last Saturday, I took a particular token, a metallic token, and I stuck it in nitric acid. There's all sorts of beautiful chemistry that happens in that particular video. You might want to check it out. It does have a certain political figure on it that, you know, I'm just going to give you a little warning there. But, you know, I'm not making any political statements. I just thought it'd be fun to, you know, demolish the token and some nitric acids. You can check that out. Darky, the equipment here, I do have a pH paper, Darky. I have that in my lab, but not down here in my basement with me. But these experiments, the magnetic stir plates ran me about $40. It came with a stir bar. And the universal indicator cost me like $10. And then it's just water and flask. You know, this flask cost me like $3 at Walmart. This one's a little more expensive. This one cost me $20. So, that, you know, it's not that much to do the experiment. So let's add a little hydrochloric acid to the flask over here on the left. Hydrochloric acid is the same acid that's found in your stomach. It's just that the stuff that I'm adding is a lot more concentrated, like 100 to 1,000 times more concentrated than what's found in your stomach. And, you know, I have some, I'm doing a presentation on Monday. I don't have any right here with me, but I do have some, you know, it would take me about a minute to go get it. All right, so long there, Dark. Can I show the color of pink, the colorless? You know, if you all put a bunch of pink hearts in the chat, I am happy to go get some of the phenolphthalein that I have. I'm gonna have to pause the live. I won't actually pause it, but I won't be sitting here jabbering on to you. Chad, I cannot make methamphetamine. I'm sorry about that. I'm not a synthetic chemist like some other chemists that you might know about. So Darky wants to see some phenolphthalein, but if any others, we got some others want to see it, drop some pink hearts in the chat, and I'm happy to go get the phenolphthalein. That particular indicator goes pink to colorless. And if I see a few more folks drop those pink hearts in the chat, I'm happy to go get them. Owen wants to see it. Darky wants to see it. We'll see how many we get. We got about 100 people in the chat, so I figure if we get to, I don't know, maybe 10 pink hearts, about 10% of folks who are wanting to engage that way, well, I'll be happy to go get it. All right. How about we check this out while we're waiting? I want to show you this here. We'll show you this particular experiment. I'm going to take this one off here. We're going to do a color separation experiment. What I have here is a fluid. Let's zoom in on the fluid. All right, we're going to zoom in on this fluid. I'll get a little closer here. Hey, Vinny Voltage, what's going on, huh? Vinny Voltage. You are like an electrician, Vinny? What kind of experiments do you do on your channel? Yeah, Darky, I've done that. I've made green by adding equal amounts of acid or base. Here we go. Let's look at what happens in this particular fluid here. I'm going to add some purple here. Let me turn this light on so you can see it. Everything's about the lighting, huh? So I'm going to add some violet, neon violet food color to this bottle here, okay? Darky, the acid I'm using is 20% by weight hydrochloric acid, and the base I'm using is 20% by weight sodium hydroxide. Nice, Vinny. I'm a physical chemist. Glad to hear that you kind of look like the same. I have to check your channel out there, Vinny. So you might want to send me a PM. All right, there we go. A drop of. Look at that. We got a drop of that neon violet food dye going in there. It's doing its thing, spreading out. We got a little entropy action going on. A little spreading out of matter. Sure enough. Let's add another drop. We'll add another drop of the neon violet food dye and just watch the beauty happen. I agree, Owen. It's very pretty. I like the little clouds that kind of form down at the bottom, yeah? Those things are just gorgeous, huh? Like, what the heck's going on there, huh? There's something happening. Happens all the way through. I consistently see this. Very weird. And we got rid of another one. Freaking, tell me about it, Owen. Jeez, oh, Pete. Come on, folks, get with it. I do have some vinegar. Well, I have some acetic acid and vinegar. Okay, now watch what's going to happen. We're going to take a white solid. This is just sodium chloride, okay? Just about 50 grams of sodium chloride. And I'm going to add it to this particular flask right here. I should say bottle. And we're going to watch what happens. I got to find my funnel, though, because that's how I'm going to add the salt. It's just regular old sodium chloride. You got it, Owen. I love it. All right, here we go. Let's add the white solid. Let's add the white solid to the mixture. The white solid that I'm adding is sodium chloride. Just regular old table salt. We're going to add it. All right. I'm adding it to the fluid. And I'm going to shake this up. We're going to see what happens. That's right, Darky. You got the right chemical formula for the white solid that I'm adding. It is NaCl, sodium chloride. Let's shake this baby up. I'll back it up so you can actually watch it happen. So here we go. You can actually start to see something going on. I'm going to shake this thing up. Here we go. Let's shake it up and get that salt dissolved. So we're going to dissolve the salt in the fluid, and we are going to see what happens. Here we go, baby. Shake it up. I'm trying to get that salt dissolved, And we're going to see some cool crap happen. I'm telling you, this is cool. I was practicing it earlier, so it should work. I'm hoping it works anyway. I tried this last week, but it didn't work. Here we go. Let's see. Did I get enough? Did I get enough dissolved? I don't think quite yet. You get another shake. I'm getting close, but not quite enough. Come on, baby. Dissolve. You got to get the salt dissolved. Shaking it gets it in there a little more quickly. Come on, baby. All right, let's see if that does the trick. Is it working? What's going up, Chemicode? I think I'm going to need... No, it's working. It's totally working, baby. Come on now. Oh, it's totally working. It is totally working. I think I might need to add a bit more salt, but I'm not sure. Can you see the separation? You can see the different layers? Yeah? And it looks like the top layer has a slightly different color than the bottom layer. Actually, looks like I got 3 layers. Let me just give this one more shake. I might have to add some more salt. I may be just a little shy on the amount of salt that I need to add. Let me give that one more shake and see if it works. If not, we'll add a little bit more salt. Yeah, I think I'm going to need to add some. So we're going to go ahead and just do that. We're going to add just a bit more salt so I can get this to work. I thought 50 grams of salt would be enough, but apparently it's not. I got to keep that in mind for the next time. Here we go. I'm just going to add a bit more. Probably a couple more grams should do the trick. There we go. All right. Give this baby a shake. So you might guess that the fluid that was there at the start was actually a mixture. It wasn't just water. It was water and acetone. And to that mixture of water and acetone, I added some purple neon food coloring. And then, it mixed all the way through. And then I added some salt. And upon the addition of salt, we're seeing a separation, right? We are definitely seeing the separation. So you can see down here at the bottom, it looks a layer here. You can see a layer at the top, and you can see a layer in the middle. We got another one. Jeez, these people, man. God almighty. Yeah, so what happened here, when I added salt to the mixture of acetone and water, what happens is the salt dissolves in the water, and it causes very strong attractions to get set up between the salt and the water. And so, because those attractions are so strong, the acetone can no longer remain dissolved in the water. And because of that, what happens is the acetone gets pushed out. Now, what's interesting about this is you can tell then that the violet dye that I added, the neon purple dye that I added, there's actually 2 different dyes in it. Yeah? One of the dyes likes the acetone layer better, and the other one that likes the water layer. And I think I've got quite a bit more water than I do acetone is all that's happening there. Yeah, that's pretty cool, though, yeah? We did at least get the two layer separation. Yes, indeed. That's correct, Darky. The acetone is less dense. Purple dip. And we're putting another one in timeout. My God, man. They're all out tonight, man. We got some real winners here tonight. We got some real winners in the chat tonight, man. It's kind of fun getting to block all those knuckleheads. What's the most toxic chemical I have? What an interesting question. I don't really know. I don't really know. Thank you there, Chemicode. I appreciate that. I very much appreciate that. I mean, yeah, just look, this channel, we want to keep it positive, folks. So just, be respectful to people. Dark Lamb, I have never tried putting cesium in water. The lowest I've gone on the alkali metals putting in water is rubidium. And I've done that twice. And both times the beaker broke. And one time I burnt a hole in the desk. The rubidium got on the desk and it was continuing to burn because it was wet, and it burnt a hole in my desk. So yeah, isn't that cool? We got a little separation over here. Kind of nice. Got like a 2-layer effect going on. Pretty cool. All right, we can pop this one back on. So Chemicode's only tried sodium and lithium. Yeah, I've done... Hey, welcome to the Alkali Metal and Water Club, right? Oh, it's fun, man. What a fun reaction. All right, over here on the left, I'm going to add some hydrochloric acid. And that's going to cause a color shift to red or more red. Lithium's underrated, huh? Yeah, Dark Lamb, I like getting my lithium from button batteries. We got another one out of here. Man, why are they out tonight, man? The monsters are out. Telling you, the racists are out today. Just ridiculous, man. Yep. Is that what it is? Do I have anything hydrophobic? I do. I have some oil. I mean, you know. Yeah, I agree, Dark Lamb. What do I think is the rarest element in the universe? Asks the special keynote. Well, I think in order to answer that, I'd have to have a better knowledge of astrophysics, of, stellar nucleosynthesis. But I do know that I believe this is correct, that the rarest element on, thank you there, Bowie, the rarest element on the, currently known periodic, well, I don't know about that. The rarest element that's found in the Earth's crust, I think is it thallium? No, it ain't thallium. Which one is it? I'm having a hard time. Astatine. It's there's only like a few grams of it at any point in time in the Earth's crust. Oh, so Derek, what did I put in here? What I put in here is, okay, let's talk about what's going on here, okay? We'll talk about what's happening here. Dark Lamb, drop some facts about astatine. Asking me what it decays into. Let's see. Astatine would be 85. So it probably undergoes alpha decay. So it's going to go to bismuth, is my guess. J Knight, that would be an oscillating chemical reaction. Okay, so here's what we're doing here. In these flasks, I have added a mixture of chemicals known as universal indicator. Universal indicator is also known as rainbow indicator, and it's just an acid-base indicator. But what's nice about universal indicator is it changes to a variety of colors depending upon pH. pH is simply a way that chemists describe mathematically how acidic or basic something is. And the way here, I'll turn this light on so you can see the scale that universal indicator displays. You got it, J Knight. So it is, like over here, it's violet. That means it's pH 10. And the way the pH scale works is if you're at pH 7, it's neutral, neither acidic nor basic. The higher you get, the more basic you get. So this is very basic. And you can see like a pH gradient here that goes from purple to blue to green. And so that pH gradient is going from pH 10 to 9 to 8 all the way to neutral. Although it kind of looks like the whole thing is going basic now. I'm going to add a little bit of acid to try to neutralize the base here. So I've added a little acid over here to this flask on the left. And that will start to show some more of these colors that are red, orange, or yellow. Again, the further you get from 7 on the acid end, the more acidic you are. So this red line that you see here, that's like pH 3. It's very acidic. If you see an orange, it's like pH 4 or 5, medium acidity. If you see a pH 6, it's going to be slightly acidic. 8.1 hour half-life for astatine, it looks like. Here we go. A couple drops of acid on the left. Couple drops of acid on the right. Very cool. And just for fun, got a little cosplay going on tonight. We're doing some chemistry together, folks, so I figured I'd dress the part, right? All right. We're not making any weapons. I don't make any weapons. The acid I'm putting in is hydrochloric acid. It is the same acid that's found in your stomach. It's just that the stuff that I add is like 100 to 1,000 times more concentrated. You guys like that? I'm not making any of that, Dark Lamb. I'm glad you like that, huh? A little bit of fun here. A little bit of Breaking Bad fun, y'all. Little bit. Does the universal indicator get consumed in these reactions? It does not, Jared. It's a completely reversible reaction. So I see there, smiley face. I don't know what else to call you. I can't really see your name. I'm adding some base over here to the flask on the left. We're going to add some base to the flask on the right as well. Simon's only heard of Breaking Bad, but hasn't watched the show yet. It's a good show. It's a good show. Quite a bit of chemistry in there. Wish there was a bit more. But there's plenty enough. It is a great show. Here we go. A little bit more acid over there on the right. Why does everyone think radioactivity is green? Yeah, agreed, Chemicode. It doesn't have much to do with green, huh? Probably because they're used to seeing like the uranium glass. What is the universal indicator made of? Great question there, Derek. Let's talk about that. What is universal indicator made of? I got to turn this light on. I got to turn my instructional light on so you can see this. So universal indicator happens to be made of 4 different dyes. What's going on up there, Cy? 4 different dyes. Those dyes happen to be thymol blue. This is sort of the workhorse of universal indicator. Thymol blue is going to display like a red, like a yellow, or blue at different pH values, okay? That's thymol blue. To that, we add a little methyl red, and we also add some bromothymol blue, and we also add some phenolphthalein. And these 4 indicators together make the universal indicator. Yes, I have, Elmira. You got to check out my shorts I have on my YouTube channel. I put a Scrub Daddy in Piranha solution. It looks kind of cool. So you might want to check out my shorts. My shorts do fairly well. You might want to check those out. Piranha solution is indeed fun. All right, let's add a little bit of acid to the flask over here on the left. We're going to add a little bit of acid to the flask over here on the right. Just watch what happens. 1 a.m. for Gigabean in London. Holy cow. For me, it is 8 p.m. You're welcome. Thanks for the question there, Derek. Hello, John. What's going on? What is going on? Hope you all are having a great time. And we're doing some chemistry here tonight. So, I thought I might dress up for the part while we do a few experiments. I even grew this little goatee for you, just trying to look the part. I'm not shaving my head, though. All right. Here we go. You got it, John. You got it, John. Here we go. Let's add a few drops of sodium hydroxide to the flask on the left. By the way, that flask on the left is like 5 times the volume of this little flask over here. I hear you. I hear you, smiley face. You know what? I've never messed with mercury fulminate. Silver fulminate works well enough. That's the stuff in Pop Rocks, or those little poppets, right? Yeah. Sure enough. Cool stuff. You guys gonna do that color separation experiment again? Huh? Jared asks, what led you to make these educational videos on YouTube? I just kind of fell into it, Jared. So I write a blog for chemistry teachers on this website called the Chemical Education Exchange. And because I always like doing experiments in my classes, my blogs were always about doing just that. Doing chemistry experiments for your students to try to make it come alive a little bit. And so I wanted to put videos on my blog, And the person who ran the site said, well, they couldn't support that, but what they could do is, if I just made YouTube videos, and I could just, provide a link to the YouTube, and they could put that on the site. And then really, that started for me in 2013. So I started my YouTube channel in 2013. And, I was just making videos for chemistry teachers. And my channel really took off in the spring of 2021 when I started doing shorts. You were here when I did the ice, probably the dry ice, huh? It's 6.02, baby. It was 6.02 where pizza's from. Come on, man. 6.02. Great time. Thanks, Air Show. Appreciate that. The Almira, the concentration is 20% by weight sodium hydroxide. Yes, Bowie, most cleaners are made from base. I would love that, ChemiCode. Here's the deal, though, bud. I'm not real fluent in Discord. So, but I'd love to join. I'd love to connect. I really would. But I haven't gotten fluent in at Discord. But yeah, I'd love to check it out. What brand is my microwave? I think I've caught up with the comments here at this point. I don't even know. I don't even know. And Brian, I can't do that. I cannot do that. All right, let's try this. Let's try this experiment. I think I got another one ready here. We can do this. Where's my... Here we go. I've got some fluid. Thanks, there, Jared. Do you do videos? Do you have your own YouTube channel, Jared? I think this is going to need some more, but we're going to try it anyways. It's all right, Bowie. Yeah, it is. Unfortunately, I guess wouldn't it be great to sort of have a chemistry course where you didn't need a bunch of math? Sort of just like chemistry appreciation. I would love to develop such a course. I really would. All right, so we're going to do this experiment. I'm not real sure how it's going to work. I don't think I quite have enough acetone in here. ChemiCode. Hold on, I got to write this down. ChemiCode, are you talking about your posts here on YouTube? I got to write this down. ChemiCode, because I'm going to forget. ChemiCode posts. Got it. Cool there, show. Don't know, James. I love The Incredibles, Simon. Okay, so, Subash, you're right. There's acetone in this bottle. Can I say that again? Sound cut off. I apologize. I don't understand. Okay, so here we go. I have a mixture. This is basically a mixture of acetone and water. So it looks like one single fluid, and that's simply because acetone and water mix very well in all proportions. Now, to this bottle, I should say, of acetone and water, I am going to add a single drop. Thanks, Sir Bowie. I appreciate it. I appreciate that a lot. I'm going to add 1 drop of purple neon food dye. I got this. Here it is. This is the color I'm adding. Purple neon. Okay? So in it goes. In goes 1, 2 drops. This isn't going to be perfect because I think I need a bit more acetone in the flask. And I tell you what, while you're watching all this spread out, I think to get a better effect, I'm going to go get just a little bit more acetone. This is going to take me a minute. Hang on there, folks. Okay. I'm back at it. I am back at it. Thanks for being patient with me. I'm going to add a little bit more acetone to this flask. Through my funnel here, we're going to try to top this off. I think this is going to help. Okay. Maybe a bit more, just a bit. And then I'm going to need more salt. So this is going to be challenging here, trying to get all this salt in. Okay. So, to recap, this is a mixture of acetone and water. All right, let me mix this up so you can see that the mixture of acetone and water it fully mixes. Fully mixes, we can tell that because the dye that I have added is homogeneous, right? Through the whole thing. And actually, now that I've mixed it, I can take a little bit out. That's going to be helpful when I put all that salt in there. Let me just take a little bit out. Okay, that's going to help. So, we've got a mixture of acetone and water. Okay? Acetone and water. Now, to this mixture of acetone and water, I am going, I've also added the violet, neon violet food dye. So, I've also added a little bit of this stuff. That's been in there. Okay, now I'm going to add some sodium chloride. Let's add some salt to the mixture. Here we go, baby. In goes the white solid. I'm probably going to need to add a little bit more. So let me just go get a bit more salt to make sure this works. Where's my salt? Right here. A little bit of salt. That's way too much. We'll pop this in there, though. Where's my funnel? Add a bit more salt. Ooh, that would have been bad. I almost did it off the side. All right, that's probably going to be enough. Here we go now. We're going to mix this up. We're going to see what happens. Oh, you're not going to want to miss this. This stuff is cool if it works. I think it's going to work. Here we go. Mix that up. Get that salt dissolved in here. Now, what happens when you add salt to a mixture of acetone and water is the salt dissociates into ions. And those ions dissolve in the water. And the attraction between those ions and the water is so strong that nothing can overcome that attraction. It's kind of like when two people really fall in love deeply, they start to date each other exclusively or see each other exclusively. So as I'm mixing this up, it's kind of like the salt and the water are finding each other, and they like each other so much that they're dating exclusively, so to speak, and that's going to push the acetone out. Let's watch it happen. You can totally see it. I'll turn this thing off. Turn this one off. You can see the separations. Up here at the top, you can see the acetone layer. Yep. Down here at the bottom is the water layer. It looks beautiful. Come on, man. Look at that. Look at that. That's just gorgeous. So you can totally see the acetone layer. It's been removed because the salt and the water are so attracted to each other that the acetone cannot overcome it. Isn't that cool? Yeah, acetone crashes out. You can say it that way. Some folks call it salting out. And what's interesting is we can also tell that the the neon violet food dye added has two different dyes in it. And one of those dyes dissolves in the water layer better, and the other one dissolves in the acetone layer better. Let me shake this up just one more time, and we'll watch that color separation again. We chemists call this salting out. Thank you there, Chemicode. Thank you there. It's a pretty easy experiment to do. You can do it with alcohol as well, but the separation of the neon violet food dye only works with acetone and acetone, salt, and water. By the way, right now you can see three layers. There's the acetone layer, there's the salt water layer, and in the middle there's a mixture of these two. It's transient though, and it shrinks. Here, we'll make it again. So we're going to make that transient mixture, and when you're doing these experiments, that transient mixture, right here in the middle, you can see it, that's a mixture of everything. That's the salt, that's the water, that's the acetone, and that's both dyes. It's a transient layer that shrinks. We call that an emulsion layer. So we have the salt water layer that looks violet at the bottom. We have the acetone layer that looks like a neon pink at the top, and then there's an intermediate color, that's the emulsion layer. That's right, Corella, used to separate solvents in the lab. It does look a little bit like oil. It's really pretty. Yep, you can use that Chemicode to concentrate the rubbing alcohol. Indeed, you can do that, sure. It does, name. It totally looks like it. I never thought of that. But yeah, this would be a great thing to do maybe for Pride Month, huh? It really would. Is this positive or negative deviation of Raoult's law? Okay, Raoult's law. Oh, Raoult's law. This Raoult's law has to do with vapor pressure, correct? 38? I think Raoult's law has to do with vapor pressure. So unless you're talking about another aspect of Raoult's law. You want to mix it again? Yeah, I can mix it again. Yeah, but 38. Does Raoult's law also speak to, I think it might be, there's like a Gibbs equation to describe different phases with different numbers of components. Oh, cool, Corella. Hey, and I thought for you all that I'd dress the part tonight since we're doing some chemistry experiments. You know, I thought it might be a little fun to grow you a little goatee, and although I exude, I think, a little bit too much positive energy to be Walter or anything like that. But my grandfather's name, this is no joke, my grandfather's name was Walter. But Walter, my Walter, Walter Allen, man, he was just such a great positive man. He wouldn't. My grandpa never broke bad. Wasn't gonna happen. I don't see myself breaking bad either. That doesn't mean I can't dress the part though, just for a little bit of fun, eh? All right, back to the experiments. But like maybe in liquid form because it indirectly affects the vapor pressure. Yeah, I mean, certainly, you know, when we dissolve salt in water, that's gonna lower the vapor pressure of the water. Certainly, right? And certainly as well, you know, I would imagine, you know, before we added the salt, the mixture of acetone and water, that's going to have a fairly low vapor pressure. All right, Chemicode, thanks for hanging out. Thanks for hanging out. Corella, that's the idea. Just to have a little good time, huh? Just to have a little good time. All right, let's go back. I'm going to add some, I'm going to add some hydrochloric acid, this flask over here on the left. It's like a 1 gallon flask, a 4-liter flask. That's the whole idea. This turned out really nice. This experiment worked out really nice. Well, Syad, let's do some dry ice experiments. That's the one thing I got left. Let's do a little bit of that. That's always kind of fun. So I'm going to put this flask on here, which is basic, and we're going to put some dry ice in there. I don't want to put too big a piece in there. I don't think I'm going to need to, I'm not going to need to put stir bar on. So we're going to put some dry ice in there. Everybody drop in the chat if you happen to know what dry ice is. It's important for this experiment. Here we go. Here we go. A little bit of dry ice. Dry ice happens. There you go. Subash, the chemist, has entered the chat. Dry ice is basically carbon dioxide. It just happens to be in solid form. And I'm going to drop a little bit into this flask over here. Thank you there, Syad. Yep, Chemicode, you got it too. Dry ice is solid carbon dioxide. We're going to drop some of the dry ice into this flask, which is at a pretty high pH, right? It's like at pH 10. So the pH is very high, which means it's basic. I'm going to drop a little piece. So I break it in there. Here it is. Here's the piece of dry ice. You'll notice that I'm wearing a glove so I don't cold burn my hand. In goes the piece of dry ice. And look at that color change. We went from a high pH down to, man, that's like a pH of 4 or 5 right now. That's a little too much water. That's just a bit too much. Let me get some of this out. It's bubbling over just a bit too much. Making a little bit too much of a mess. Look at that. And so that easily tells us that dry ice when it dissolves in water, when carbon dioxide dissolves in water, it forms an acid. Isn't that cool? Now, watch. I'm going to go ahead and start adding some base to increase the pH. Here we go. Give it a good squirt. And watch what happens when the carbon dioxide bubbles through. It's neutralized. And sure enough, we're now at an acidic pH. Yellow, right? Yellow color, that means our pH is slightly acidic. Kind of neat, isn't it? Let's add some more base again. Here we go. A little bit of base. A little bit more base. Violet. And as long as that carbon dioxide is bubbling through there, it'll continue to make it acidic or neutral. Can I add dry ice and cold nitrogen at the same time? So 38, I have done that experiment. I've not added them both to water at the same time, but I have done an experiment where I've seen what happens. I've looked carefully at what happens when you throw dry ice into liquid nitrogen. That's going to be on one of my shorts. It's actually maybe a year ago I did it. So you're going to want to check out my short where I asked the question, what happens when you mix dry ice and liquid nitrogen? Just check out my other channels here, or my other shorts here on Tommy Technetium. Can I add, what's this? And it's an interesting effect. It makes sense once you see it, but it's kind of fun to see. All right, this is now pH 6, which is slightly acidic. I'm going to add a squirt of base. We're going to make that pH 10. And as the dry ice continues to bubble through the solution, it'll pull the pH back down low again. That's right, Corellia. Now, I'm going to get a little technical with you here. What's interesting, Corellia, is that carbonic acid, H2CO3, actually, for all intents and purposes, it does not exist in aqueous solution. I mean, it does, but it disintegrates. It decomposes in I think it's like 300 nanoseconds. And so it is appropriate to say that when carbon dioxide dissolves in water, that the CO2 indeed is in the water, but there's pretty much no carbonic acid. However, some of the CO2 obviously reacts with water and forms protons and bicarbonate. And it's those protons that lower the pH. Thank you there, 38. Corellia, it doesn't quite decompose into CO2. It decomposes into bicarbonate ion, and I guess it would react with water. I don't know how much chemistry, it looks like quite a bit, so you'll probably understand when I say that the CO2 reacts with water to form the bicarbonate ion and the hydronium ion. Thank you there, Derek. I appreciate that. And I hope you all are, for the United States, I hope you're all, standing up for science. I mean, it looks like there's some changes coming, and hopefully with those changes coming, people will still see it valuable to put money into scientific research. I think I recently saw that I think they pulled the plug on Alzheimer's research. There's a lot of NIH, National Institute of Health research that funding has been pulled the plug on, and that, that's not going to bode well for health in America or around the world. So hopefully we can, get back to getting that stuff funded. Thank you there, Syed. So why do they use carbonic acid to carbonate water? So Corellia, what they actually do is they just bubble carbon dioxide into water to make carbonated water. That's what's done. Carbolic acid, yeah, I didn't remember that, 38, but there's a difference between carbolic acid and carbonic acid. Very nice. And looks like we've got a buffered system now, which tends to happen when you start messing around with carbon dioxide and water. I haven't, immigration. Have you? Have you worked with fluorantimonic acid? Well, I mean, Corellia, I wouldn't say they're lying. I would just say that, there are ways that we describe what's going on. And I'm getting very technical. Like I didn't know this. I've been a chemist for a very long time, and I didn't know this until like 5 years ago. I was talking with a colleague who happened to know more about it. And he's like, hey, Tom, actually, you know, uh, carbonic acid does not exist in solution. They can detect it in the gas phase. They just don't detect it. I mean, they do detect it in water, but like I said, they detect that it disintegrates in like 300 nanoseconds. So that's I guess that's a real issue that we folks who are involved in science should be talking about. And I do this a lot as a teacher. There's sometimes that I essentially lie to my students, but I tell them the basic idea. And to communicate the basic idea, I tell them something that's simpler to understand. It approximates the truth, but we know things a little bit better than what I'm telling them. And I just don't want to go into the details because they can learn that later. As an example, the Bohr model of the atom. I often will use the Bohr model of the atom in my teaching. So you just talk about it. The electron happens to be this distance from the nucleus. That's the quantum mechanical atom doesn't talk like that. We don't know how far the electron is from the nucleus. But sometimes we just talk about it that way, and I don't know, man. So they say they mix it on water, and that generates CO2. They mix carbonic acid with water, and that makes CO2. I can make Aqua Regia 38. I can make Aqua Regia. So yeah, I've pretty much done all the experiments I got for you tonight. I blew out all the stops tonight. Not sure how much longer I'm going to be hanging in there with it. And what I normally do near the end of the live is I flip the camera around. I talk to you for a little bit so you can check out my goofy cosplay costume I got on for you tonight. I might continue to start wearing these for the live. Son of a bitch. Get out of here, you racist son of a biscuit. Come on, man. Come on, people. Come on, man. This is a channel where we were going to respect each other. And if not, you can go to another channel. Just go to another channel. Crying out loud. Ha! Pretty nice, 38. And you heard about that. So, 38, during World War II, I'm not sure I'm allowed to say the word on YouTube. I don't, but there was, you know who I'm talking about. The bad guys in World War II in Germany. They were looking for gold for use in military stuff, and they were, ransacking labs looking for gold. And there was this guy. What was his name? I can't remember his name. Anyway, there was this guy I don't know if he was in Germany, he was somewhere, and they were afraid that they were going to take the Nobel Prize medals from Nobel Prize winners. And so this guy, if I can remember his name, somebody may be able to remind me of his name. Anyway, he took Nobel Prize medals from Nobel Prize winners to hide it from the bad Germans, and he dissolved them in Aqua Regia. And his lab got ransacked with, they were looking for him, and they couldn't find him because he dissolved the metals in Aqua Regia, and they were just sitting on his shelf. And then after the war, he was able to recast, he was able to precipitate the gold back out and recast them for the Nobel Prize winners. Subash, I think at the time it was. I think at the prize. Yep. It's not Escobar. Yep. I can't remember his name. I apologize. Yeah, it was pretty. And what's cool about it, this is like the coolest part about it. The guy who did this a few years later ended up winning a Nobel Prize in chemistry himself, which is kind of cool. All right, so we are going to flip the camera around. I'm going to talk to you all. Had enough doing experiments for tonight. Let's just chit chat for a bit, and then we're gonna. No, it ain't Fritz Haber. It's not Fritz Haber. I think his name began with like an L. Is what I want to say. Dang it, his name is right on the tip of my tongue. There's like 3 times I've almost been able to remember his name, but I can't remember it. It wasn't Fritz, and I know I'm saying that last name wrong. I don't. It's not Haber. I don't. Yeah, if I remember correctly, he's a little shaky, huh? Yep. Ha, Armado. Yep. So yeah, we did some chemistry experiments tonight. We had a good time. We did like 3 different types of chemistry experiments. One we always do. We just do like universal indicator color changes, like beautiful color changes. And then we did some separations. This one worked a lot better. This one worked much better. Where I was able to separate neon violet food dye into like a neon pink and a neon purple. That was kind of fun. And then we put some dry ice and water, and we walked through that and looked at the different color changes that occurred, that was kind of fun. It was kind of fun. Thanks there, Gigabean. Appreciate it. Thank you, Gigabean. So yeah, we did some. I usually do either 1 or 2 lives a weekend. Just doing experiments with people, for people. I wish 38. Thanks there, Derek. I appreciate that. I do. We had a good time. We had a real good time. So thanks for joining in. It's great to have you along. Love doing these experiments for people. You got it, immigration. You got it. Which is very helpful, right? Which is very helpful. Thanks, Derek. I appreciate that. I really do. Make sure you comment on 1 or 2 of them so I know you were there. I read all the comments that YouTube sends to me, and I think they're most of them. Interesting, Subash. Not a whole lot. I stab. I do, like, I made a battery, like real easy stuff. Real easy stuff. I made a battery using Play-Doh as the salt bridge, basically, is what I did. All right, Gigabean, go to sleep. We'll see you next time. A little too late this time for you. Great to have you here as always. Gigabean, man. Gigabean is here all the time. Great to see them. All right, folks. That's correct, Corellia. Is that PM or AM, I stab? I hear you, John. I hear you, John. AM, okay. You're like on the other side of the world to me. You're basically on the other side of the world, which is so cool, man. That is so cool. Why chlorine has more electron gain enthalpy than fluorine? Well, I wouldn't think that. That's a great question, 38. I don't know. Thanks there, Minnie. Appreciate that. I'm over here in the United States, so I stabs from Thailand, yeah. 38 to 7 a.m. So we got folks from all over the place, which is really cool to hear. Really cool to hear. Yeah, we've had a great time chatting. It's interesting to watch you all talk with each other and with me. We got someone from New Orleans. I love New Orleans. I've been there, I think, 3 times now. What a great city. Man, what a great city. Not often, Minnie. Not often. Thanks, iStab. I appreciate that. very much. Thank you. Thanks there, Derek. I appreciate that. Probably ought not give out all too much identifying information, Giga Bean. United States is enough. Well, hey, folks, it's been great hanging out with you. Thanks for, for those of you who, are always here commenting, keeping it fun. The comments that you all give to me, it helps me keep my energy up. I think it makes the live a lot more fun for folks. So, I appreciate that. Looks like we got a conversation going on about electron enthalpy with fluorine and chlorine, which is kind of cool. I'm gonna have to look that up. I'm gonna have to look it up and see what's going on with that, because I'm a little confused too. But nevertheless, hey, thanks for checking out some beautiful science experiments with me tonight. And that beauty of science, as I like to say, man, it's everywhere. It's just the universe is so freaking amazing. All this crap that's going on, and we are privileged to be able to watch it and figure out some of what's going on, which is really remarkable. Absolutely remarkable that we can do that. So thanks for hanging out here, learning some science, teaching me some science, watching some science together, chit-chatting about science and life. And, I wish you the best in all your endeavors, and stay positive, keep moving forward, and make this world a better place for yourself and others. We'll see you next